This will be for the con exercise. Restrict domains of functions to make them invertible. So just a quick Google definition of the vertical line versus horizontal line test. Okay, we'll be using the horizontal line for this exercise. It says if a horizontal line cuts the curve more than once at some point, then the curve doesn't have an inverse function. So that's what we'll be using here. Okay, so in short, if you have a curve, the vertical line test checks that the curve is a function. The horizontal line test checks whether the inverse of that curve is a function. All right, so it says function f graph below is not an invertible function. Function f is a quadratic function. So we can see before I even scroll all the way down, we can see from the horizontal line test, whoops, we can see from the horizontal line test that this function does not have an inverse. Okay, because if I draw a horizontal line, it hits the graph or function in more than one place. Okay, so that means if we exchange the x and the y, it would have more than one output for each input. So if you do the horizontal line test, if it intersects the graph more than once, it is not invertible. Okay, so we can see that right here, and they told us in the write-up that this function is not invertible. All right, they asked to which intervals could we restrict the domain of f to make it an invertible function. Choose all answers. All right, so it might be more than one. So let's try x is greater than or equal to 0. All right, so if we go to the x-axis, this is x equals 0, so that's this entire line right here. That's x equals 0. So if we restrict the graph or the function to everything that's greater than or equal to 0, now can we still do the horizontal line test? Well, yes, if you start here, it intersects just once. Right here, it intersects just once. Wherever you go, even if you went all the way down here, it would intersect the graph in only one point. Okay, so if you eliminate this side of the graph and only use x is greater than or equal to 0, then that is now an invertible function. So A is true. Let's try B. X is between 4 and negative 4. Let's try it. All right, so here's x equals 4. Here's x equals negative 4. So we're only looking at this section of the graph. Does it pass the horizontal line test? Well, no. If you draw a horizontal line right here, it intersects here and here. That's more than once. And same thing if you move up. Intersects here and here. So in this case, the answer is no. This is not invertible, even if you restrict it from negative 4 to 4. Let's check answer C. X is less than or equal to 0. All right, so on your x-axis, go to x equals 0. That's this line right here. And we're looking at everything on the graph that is less than or equal to 0. Can we do the horizontal line? Yes. Okay, it intersects once. Wherever you go, it will only intersect once. All right, even all the way down here, it intersects just once. So in this case, the answer is yes, if x is less than or equal to 0. So answer C also works. Like I said, choose all answers. It may be more than one. All right, again, we have a function that is not invertible, and they want us to try and restrict the domain to make it an invertible function. All right, choose all answers that would make it invertible. So first we go from x equals negative 5 to 0, but not including 0. See, there's no bar under the inequality symbol. So from negative 5 to 0, but not including 0. All right, on the x-axis, here's -4, -5 is right here. And x-axis, x equals 0, but not including 0. So really, I'll draw the bar here, but it's not including 0. I should really draw a dotted or dashed line. All right, so it's not including 0. Let's try the horizontal line test. All right, so it's not touching this dot. So anything on this curve right here, it intersects only once. Even all the way down here, there's just this one point, but it doesn't include this point. So even there, it works. So the first one is yes, answer A is correct. Okay, now we're going to go from 5 to 8, but not including 8. Okay, so here is x equals 5. And then go to 8, 6, 7, 8. 8 is right here, but it's not including 8. So this would be a dash line. And let's do the test. All right, I can draw a horizontal line anywhere on this graph and have it intersect only once, even down here. So that is invertible. Last one, let's check C, going from 0 to 5, but not including 5. Okay, here's x equals 0. And x equals 5 is right here, but we're not including that. I'll make it a dash line. Okay, so this point doesn't count. And horizontal line on anything on this graph, it's only going to hit once. It's only going to intersect once, even down here, because 5 is not included, so this doesn't count. So again, it's still invertible. So C is also correct. Choose all answers that apply. All 3 answers apply. And by the way, if you see a hole in the graph, that means there is no y value at that point. So just so you know, at like x equals 0, the y value is y equals 0. At x equals 5, the y value is 0 because it jumps from here to here.